Hey everyone. Um, Oftentimes, when we're dealing with control systems, it's highly recommended that we monitor the health of our devices and the communication across the network. In this video, I'm going to demonstrate how we can achieve that in an Allen Bradley PLC-based system. And as you can see here, I have in RS Links, I have the few devices I'm using for demonstrations. So I have a couple compact Logix PLCs. I have a PowerFlex drive, an ETAP, and a Control Logix rack where I have a few modules in there, as you can see in here, between analogs and discretes. Now all these devices are communicating to each other across Ethernet IP protocol. So let's switch to the PLC to see what's going on in there. So in here I have this add-on instruction that I put together to allow us to monitor up to 32 modules and devices at once. Now traditionally, one of the ways to monitor a module or controller and so forth, we typically use the GSV instruction that will allow us to monitor a few things. So just as an example here, if I'm looking for the module, then I can pick a module here, and then in the instance name I can pick, for example, the let's say this compact Logix, for instance, and then I can choose an attribute. So there is a few attributes here to pick from, or you can use the entry status that will give you a code, and you can use that code or interpret the code to know what's going on. Now, the limitation with this method is it gets very quickly impractical when you have few modules and devices to monitor and so forth. So because of that, we can use this instruction that will allow us to, like I mentioned, monitor up to 32 devices, and with that has been said, I can have 10 rungs of these add-on instructions, for example, and that will allow me to monitor up to 320 devices. So it's a very, very practical and efficient way of doing it. Now, from a configuration standpoint, show you here what's going on. So if I open up the add-on instruction, I have a message. I have configuration path and the maximum devices that I want to monitor. So those are the three parameters that I have to set up. And once those are set, then the add-on instruction is good to go. So let's look at the first parameter we need to set, which is the message instruction. So in here we simply need to pick SIP generic and then device who in the service type. That's all we have to pick in here, and then assign an array where the result of this transaction is gonna be stored. And then from the communication tab, we can just point to any module in our program. It doesn't matter, the add-on instruction will take care of that behind the scenes. And then the next parameter is the config path. So in here where I have to specify the path to each of the module or devices I want to monitor. So in here I have 13, so I'm monitoring the compact Logix itself, the one I'm running this program in here. I'm monitoring the slot 1 and 2, which is these two guys here, the relay output and the analog input, as you can see in here. And also I'm monitoring the compact Logix, which is .10, and then PowerFlex, which is .20, and the ETAP, which is .30, and then the Control Logix rack. And I'm also monitoring the cards that are in the control logics card, including the processor, which is in slot 0, as you can see here. Now this path has to be entered here in hex. Now one of the way that I find relatively easy to find what to put in here is, which I'm going to share with you here. You can just simply add here just a dummy message instruction, and then just compile. Okay, so once I have that, I can just simply go to the communication tab and then browse into my IO configuration in here, and let's say I'm going to point to this PowerFlex for example, and then hit apply, hit OK, and then I can monitor this tag in the monitoring tags tab, and if I expand this test tag, I will see here right there the path. So I can simply just copy this and then paste it. If I copy that and then go back to my add-on instruction, you will see in here under path that for the PowerFlex, that's what I have in here, as you see. So it's the same deal. So I can just get rid of this now and hit OK. And with the same way, you can add all these paths in here. And then the other parameter we need to configure is the number of devices we want to monitor. So I put here already 13, but we can go up to 32 as I mentioned. So that's about the settings we need to do in here. So the first thing I would like to show you is monitoring the communication to these devices. So I'm just going to pull here a prompt command. So just pull it here, and then so we can see also what's going on here. I'm just going to put this in here, and let's open up our add-on instruction. So for example, the control logics rack is in path number 6, so that's bit number 6 in the statuses. And as we see here, it's showing us it's 1, so then right now it's mean that it's communicating in healthy. So if I go and here just to confirm and put the IP address, you can see it's communicating. So now I'm gonna go and unplug it from the network. So as you see, the status changed to 0, and it's in timeout right now. Now if I put back, plug it back, you can see communication is back, and then the status is going to update here to 1, as you can see in there. So just as simple as that, and we can do the same with the same way to, for example, the PowerFlex, which is .20. So as you can see here, we're talking to the drive, and it's bit number 4. So if I unplug it right now, we can see that the bit turned to 0 and the communication is lost. So we'll put it back in, and then it should reset itself. So as we see here, the communication is back and the bit is also healthy and everything looks all right. And with the same method, we can monitor all the other devices communication wise. Now the other thing we can do, or we can monitor here beside the communication, is the health of our modules. So if we see here, for example, if we take this slot 3, for example, in the control logics rack, we see that there is, it shows us that there is something abnormal. And if we open it up, there we go. So we have in here an issue with the electronic key being mismatched. So it's detecting that for us. Now if we go to our allo instruction and we look at our path, so slot 3 in here is bit number 10, as you can see here. And if I go to the status, we will notice that bit number 10 is 0, as you can see. Now I can go back to that module and disable the key, for example, just to make it healthy. So if I go here and say, let's disable the key for now, apply, yes, okay, so it's running and looks it's healthy. So if we go back to our status in here and look at that bit number 10, we see now it shows us 1 and it's healthy. We can notice here that number 7, for example, is unhealthy, and number 7 is, if I open up the paths in here, it's pointing to the processor in the control logics rack. So if we open up that processor, which is here, slot 0, and go to the module info, we can see that it has indeed a minor fault recoverable, and we can detect recoverable faults, minor faults, and also we can detect major faults that are recoverable and non-recoverable. The other thing I would like to show you here, we can also detect if a module has been unplugged from the rack, and also if we put the wrong module in a given slot. So I'm gonna unplug this module here, and then we will see. Now that module is bit number 8 right there, so it shows right now it's healthy. So let's unplug it here from the rack. And as you see, it immediately shows us that is now 0, meaning that the module is not present in the rack, that it should be present. And also, if I push back, it's going to reset itself automatically. And as you saw here, I push back and now it's back in healthy and normal. So the last thing I'd like to show you is I'm going to put the wrong module, as I mentioned earlier, in that slot number 1. So I'm just going to put this card here, the OF6VI, in slot 1, and then we'll see what will happen. Okay, so I just put the analog card in there, and you see the bit is it's still 0. It says something is wrong. And indeed, if I go to slot 1 and open up the configuration interface, we can see in here in the module info that here is the card. It's an analog, but it's the processor expecting discrete input, so that's why it says it's unconnected. So even in scenarios like these where we accidentally put the wrong module in a given slot, we have the ability to detect such a event. So now I'm gonna put back the modules, and we should be able to see now that the statuses of bit 8 and 9 are healthy, as you can see in here. So everything is back to normal automatically. Well, that's it for me, folks. I hope you enjoyed the content. Please subscribe, hit like, and share with others so everyone can benefit. Thank you for watching.